Assalamu alaikum friends, my name is Bilal Khan and this is my 6th video of DevOps. In this video I am going to show you how computers are connected together. So basically computers are connected using different topologies. So the first topology is the bus topology. In this topology only single cable is present and all the devices are connected with this single cable. As you can see that this single cable is providing connection to all the devices. Alright. So, but it has some drawbacks also. So the first disadvantage of this bus topology is this, that if this single cable gets broken, then all the devices that are connected to this cable will lose the connection. Alright, and it has some another disadvantage, and that is only one person can send data at a particular time. Alright, so as you can see that this is the receiving from this point the cable receives the data and it moves the data to the end of this cable. Alright, so if a person wants to send different types of data at once, then he can't do this. The data will be sent one by one. Alright, so this is the structure and the functionality of bus topology. Now move to another topology, and that is ring topology. As it is suggesting by name that all the computers are connected using a ring. Alright, so computer 1 is connected with the computer 2, computer 2 is connected with computer 3, and so on. As you can see that all the computers are making a shape of ring that are connected with each other. Alright, so let's move to the first slide, and I will show you an example that if I want to send the data from device 1 to device 7, then this cable will transfer the data from my device to the 7th device. Alright, and in this way the data will be transferred. But even the ring topology, if I want to send the data from device 1 to the device 7, then I will have to first go to device 2, then to device 3, device 4, device 5, device 6, and then the data will be transferred to device 7. So it will go to all of the devices and then it will reach to the device 7. So this is the functionality that how you can send the data, that all the data will first have to go through these devices before reaching to the final destination. Alright, so it has some also disadvantages. The first disadvantage is that if this connection gets broken, then all the devices will lose the connection. Alright, and it has another disadvantage is this, that it has unnecessary calls. I have told you that if you want to transfer a message from device 1 to device 7, then you will have to call all the devices and then you will reach the destination. Alright, so in this case the calls will be unnecessary because these calls are not required, but they are called to reach to the final destination. Alright, so now move to another topology, and that is star topology. So in this topology the central device is present and all the devices are connected with it. Alright, as you can see that with this central device, all the devices are connected to it. Alright, so if I want to send the data from device 1 to device 3, then the data will first have to go through the central device and then will go through the device 3. Alright, similarly if I want to send the data to device 2, from device 2 to device 4, then the data will have to go through the central device and then it will reach to the destination. Alright, so but it has a problem that if a central device gets broken, then all the connection will get lost. Alright, so now let's move to the fourth topology, and that is tree topology. So it is basically the combination of star and bus topology. In the bus topology we have seen that a single cable was present and different devices were connected with this single cable. Similarly, the cable is present, but it has not a device. These are not the devices. These are basically the central devices that are connected with this single cable. Alright, so as in the previous table, let's see that as you can see that only one central device was present here in the star topology and it has multiple devices connected with it. Alright, similarly in this case the cable will contain multiple central devices, and with each central device multiple computers will be connected. Alright, as you can see that this central device contains 2 computers, this central device contains 3 computers. So similarly all the central device contains multiple computers. Alright. So now let's move to fifth topology, and that is mesh. So basically the concept of mesh is that one device is connected to all of the devices. Alright. So let's take a look at this. As you can see that device 1 is connected with device 2. Device 1 is also connected with device 3 with this wire. Device 1 is connected with this wire to device 4. Device 1 is connected with this device 5 also. Alright. So similarly, device 2 is connected with device 1. Device 2 is connected with device 5. Device 2 is connected with device 4. And device 2 is connected with device 3. Alright. So this is the structure of mesh topology. But it has some drawbacks, and first disadvantage is this, that it is very expensive because all the connections require a lot of wires. Alright. So for this reason they require a lot of wires, and this is expensive. And the second disadvantage is this, that it has some scalability issues, because if I want to add another device to this mesh topology, I will have to connect a single device to all of the devices that are present in mesh topology. Alright. So let's take an example that if I have 100 devices connected to mesh topology, and if I want to add another device to the 100 devices, then I will have to connect all the devices to this single device. Alright. So in this way it has some scalability issues. So now let's move to another segment of the networking. Basically we have covered the broad area of the network, but now let's move to the internal part of the network, and the first part that we are going to discuss is the structure of networking. Alright. So basically there are two model structures of a network. The first one is OSI model, and the second one is TCP IP model. Alright. So basically with the help of these models, the data can be transferred from one computer to another. Alright. So these are basically providing us some layers in which the data will be transferred and reach to its destination. Alright. So now let's take a look at the first model, that is OSI model. So basically the OSI, Open System Interconnection model, describes 7 layers that computer systems use to communicate over a network. So the OSI model uses 7 layers, 7 steps through which a data will be transferred from one computer to another. Alright. So let's take a look at these 7 layers. So as you can see that layers of OSI model, the first one is application layer, the second is presentation, then session, transport, network, data link, and the physical layer. So these are the 7 layers of OSI model through which the data will be transferred from application layer to the physical layer. Alright. So there is another thing that you need to remember, and that is OSI model is important for interviews. There are a lot of questions related to OSI model that you need to keep in mind. That first you need to remember all the layer names, and then you need to remember all the functionality of the layers. So it is very important for the interviews. Alright. Now let's move to the details of each layer. The first layer is application layer. So this layer is used in the software. So basically it is showing by its name that it is specific to the application. So it is used in the software. It contains the front page of an application through which user can interact. Alright. So the user can interact. This is the through which this application layer. Alright. Like browsers, messaging application. So all the data is in front of us, like browser application through which we are communicating with each other. So this is possible through application layer. Now after application layer, let's take an example that you send a message to your friend. Then the application layer is used in this messaging application. After that, the message will be transferred to the presentation layer. Alright. So this layer transform the data into the form that application accepts. Basically this layer converts the words, characters, number, etc. to machine representable binary format. Alright. So the data that you have sent from the application layer was in the English or any language format, but it is now converting those words and characters into the machine representable binary format. so that a machine can understand what this message is about. Alright, so the presentation layer is responsible for translation. Alright, as we have seen that this message is translated into the machine representable binary format, encryption and compression of data. So it will be encrypted so that no other person can see, and compression. Compression means that, let's say if one person send a large size of file to another person, then the data will be compressed into a smaller size. Alright, the size of the data will get decreased. In this way, the file will be easily transferable to another location. Alright, so the presentation layer is responsible for translation, encryption and compression of data. Now let's move to another layer, and that is session layer. So this session layer is responsible for opening and closing communication between two devices. So it will be responsible for opening the communication or closing the communication between two devices. Alright, so let's take an example of sign up login form. You enter the user and password, and you are given access to the account. Now after some time you didn't use an account, so the website will automatically be logged out. Alright, and if you visit the site again, it will show you that please enter the email and password again so that you can log in. Alright, so basically in this way the session is used. So session will be opened for some time, and if you are not active on that website, then the session will be closed and all the data will be removed. Alright, so the session layer ensures that the session stays open long enough to transfer all the data. Alright, so the session will be open until you send all the data. It will make sure that the data is sent, and then it will closed in order to avoid wasting resources. Alright, so the session layer also synchronizes data transfer with checkpoints. Alright, so let's take an example that if 100 MB file is transferred, the session layer could set a checkpoint for every 5 MB. Alright, so after that the session will set a checkpoint that the 5 megabytes file will be transferred one by one. So the file size is 10 megabytes, but the data will be transferred 5 MB, 5 MB, 5 MB in this way. Alright, so it will make sure to set a checkpoint for it. In this case, in the case of a disconnect or crash after 52 megabytes. Alright, so let's say 52 megabytes have been transferred, but it has a checkpoint for every 5 megabytes. So in this way, the 50 will be saved, but the 2 that is not equal to 5 will be removed. Alright, so only it will reach to the 50 and the 2 megabytes will be ignored. Alright, the session could be resumed from the last checkpoint. Alright, so after 50, the session will be resumed from the last checkpoints, meaning only 50 more megabytes of data need to be transferred. Because 50 megabytes has been transferred, the 2 megabytes were ignored because the checkpoint was set for 5 megabytes. Alright, and the next 50 megabytes will be transferred, alright, to complete this process. If the checkpoint is not present, the entire transfer would have to begin again from the scratch. Alright, due to this checkpoint, the data is saved in the session layer so that it can't be transferred again from the scratch. Alright, so with the help of these checkpoints, the data will be saved in the session layer, and all the data and the remaining data will be resumed due to these checkpoints. Alright, so now let's move to again the fourth layer, that is transport layer. The transport layer is responsible for end-to-end communication between two devices. So basically this is responsible for end-to-end communication between two devices. So this includes taking data from the session layer, as we have seen that the session will take the data and breaking it up into chunks. So basically all the data that was present in the session layer will be divided into different parts or chunks, and that parts would be called segments. Alright, so before sending it into the network layer, so before sending it into the next layer, that is network layer, it will divide the data into different chunks, that is called segments. Alright, so every segment will contain the source, means the data that you want to transfer, the destination port number. It is basically, I have told you in the previous video that it is identifying an application, and the sequence number. So the sequence number is used for all the segments that the data is divided. So let's say the data is divided in 10 parts. So there are 10 segments of it. So for each segment there will be a specific sequence number. Alright. So if the data is transferred, then first of all the sequence number 1 will be transferred. After that the sequence number 2 will be transferred. In this way the segments will be transferred one by one due to the help of sequence number. So the sequence number will reassemble the segments in the correct order. Alright, so it will not it will not call the sequence number 2. Instead it will call the first segment, then it will call the second segment, and so on in the correct order. So transport layer is also responsible for flow control and error control. So flow control controls the amount of data that is being transferred. Alright, so if the amount of data is transferred, that is controlled by the flow control. And the error control is ensuring that the data is received is complete. Alright, so the data that is received is complete, and if it is not complete, then it will request to retransmit this data. Alright, to fulfill the requirement. So next move to the next slide, and that is there is a connection-oriented transmission called TCP and a connection-less-oriented transmission called UDP. So basically I have told you in the previous video that what is the difference between TCP and UDP. So TCP is used to transfer the data 100%, and UDP is not that much strict as compared to TCP. So it will allow the some packets to be lost. Alright, so it is not that much strict. So in this case, in the transport layer, the UDP is faster. How? Because the UDP is UDP is allowing some packets to be lost. So in this way, it will not care about the packets. Instead, it will care about the speed of the transport. So in this way, the UDP is faster in terms of sending packets because it does not provide feedback. That's why some data gets lost. Alright, so the data is lost and the UDP is focusing on the faster result. So it is faster than the TCP. So in another case, the TCP is making sure to send the data 100% to the destination. So in this way, it will check that none of the data is lost. So I can send all the data to the destination. Alright. So now let's move to another point layer, that is network layer. The network layer is responsible for facilitating data transfer between two different networks. Alright. You need to remember that it is responsible for facilitating data transfer between different networks, not on the same networks, but between the different networks. So if two devices communicating are on the same network, then the network layer is unnecessary. Alright, so it is not required because it is in the same network. So the network layer assigns sender and receiver its IP address. Alright, so as I have told you that the segments are divided in the transport layer, the data is divided into segments. Alright, and these segments will be assigned IP addresses, alright, in the network layer. Alright, so the network layer will assign each of the segment its own IP address so that it can reach to its destination. Alright, so breaks up the segments from the transport layer into smaller units called packets. So these segments will be divided into packets so that each packet could reach its destination with the help of IP addresses. So all the segments will be given the IP address, and with the help of these IP address, the receiving destination will be identified. Alright, so it can reach its correct destination. So now let's move to another slide and another layer. The data link layer is very similar to the network layer. Alright, so except the data link layer facilitates data transfer between two devices on the same network. As we have seen that the network layer is responsible for data transfer between different networks, but the data link is responsible for transferring the data on the same network. Alright, so the data link layer takes packets from the network layer. Alright, so as we have seen that the network layer is breaking the segments into smaller units called packets. So the data link layer taking the packets from the network layer and breaking them into more smaller pieces called frames. Alright, so the packets are divided into frames. Now the frames or the packets arrives in a network. It is the responsibility of the DLL or data link layer to transmit it to the host or the receiving side using its MAC address. Alright, so now the MAC address is the physical address of an application through which the data will be received. Alright, so with the help of this MAC address, the frame will be received to its destination. Alright, so it is with the help of this data link layer. So now let's move to another layer, the last one, the seventh one, the physical layer. So as it is showing us by the name physical, so the physical layer includes the physical equipment including in the data transfer, such as cables or switches. Alright, so all the data will be transferred physically now from the data link layer to the physical layer. So this is also the layer where the data gets converted into a bit stream. Alright, so as you can know that computer can only understand the number 1 or 0. It's a bit number, so it will be converted, the data will be converted into bit stream, which is a string of 0 and 1. From this physical layer, the data will be transferred to another computer. Alright, so after that, let's move to the table. Let's show you a graph. So first of all, you want to send a message to your friend. Alright, so how you can send it? You are not able to send the data to your friend parallelly. Instead, what you will do, you will send a message. It will go, first of all, go to the application layer, then it will go to the presentation. After that, it will go to the session layer, and then transport. The transport will divide the segments. Alright, the session layer data into segments, and the segments will be divided into packets. The packets will be divided into frames. Now the frames will be transferred in the physical layer. Alright, in the form of 0 and 1. Alright, after that, the next step would be that physical layer is connected to your friend's physical layer. Alright, so the data will be transferred through cables, and the cable will receive that data in the form of 0 and 1. After that, it will go upward in the form like data link layer, and then after that it will move to the network layer, transport layer, session layer, presentation layer, and then at the end the user will see an application in the form the data in the form of an application. All right. So this process will happen from upward to downward, and from downward to upward. All right. So this will happen like this. All right. So from upward to downward, and from downward to upward. It won't happen like this. As you can see that I have told you, it won't happen like from application layer is communicating with the application layer, presentation layer is communicating with presentation layer, and the session layer is communicating with session layer, so on. So this will not happen like this. Instead, it will go from downward to back to upward. Alright. So this is the functionality of OSI model. So now what we have learned, the first thing that how computers are connected together using different topologies. Alright. The next thing was what is the structure of network like OSI or TCP. I will be showing you the TCPI model in the next video. And the third one is that different layers of OSI model. Alright. So that's it. I hope you like this video, and if you like this video, then make sure to subscribe to my channel. And if you have any questions, then please ask these questions in the comment section below. I'll be happy to answer all of them. So till then, goodbye.